Hello, advanced English learners. Welcome back to another conversation. I'm joined by the one and only Greg.
Hello, hello.
Welcome.
Thank you.
So, we do these to help you with your listening comprehension skills, to help you build vocabulary and expressions, and learn how to have a conversation in English and be able to carry on a conversation as well as improve your communication skills. And we provide a free worksheet that you can always get by subscribing to our free newsletter by going to our website at advancedenglish.co, and then you'll see an option to join mailing list. So definitely check that out because you'll get those free worksheets that go along with these conversations. All right. Without further ado, let's jump into today's topic, which is
Drum roll.
all about space travel.
Oh, nice. I love space travel.
Yeah, that's why I think we'll have fun with this. All right, let's get into it. All right. So let's first define what we're going to be discussing in terms of space travel, because that's a broad concept.
Yes, space travel is probably originally the domain of science fiction novels. But of course, over the course of the last few decades, we've made some strides. And I think the way to discuss it today that might be most relevant is to talk about some of the developments in the companies competing for space travel. Why are we doing space travel? And in the near term, how will it affect our lives? Because obviously we can talk about the Star Wars, multi-galaxy travel, but the reality is that's not going to happen in our lifetimes, if ever. And so I think it'd be more useful for everyone if we talked about some of the specific types of space travel that we have available currently and how we might have access to that as regular people as well.
That's right. I think that's a good starting point, and we can always follow up with something more sci-fi if you would enjoy that, because we also enjoy talking about more of the science fiction out there technology. So let's start with then the more approachable way of exploring space, which seems to be SpaceX.
Yes. So of the companies currently competing, and it's funny that I'm even saying companies because historically the only way to get into space was to go through a government agency, right? Of course, in America, that's NASA. And most of the larger countries have their own space administration of some form. And the reason why that was reserved to governments is because it's really expensive to get a vehicle or anything really into space out of the Earth's orbit.
Let's talk about some of the costs associated with. So the fuel.
And they're actually not using oil. It's rocket fuel, which is a combination of kerosene and a few other ignition substrates that are very energy dense.
Because we need to be able to take these out into Earth's orbit.
That's right. So you're trying to lift something heavy. And think about when you lift a weight, 40 pounds. If you're in a gym and you lift a weight, that's a lot of work just to get that weight off the ground.
So 40 pounds or like 20 kilos, just for some context.
Exactly. That's tough to do.
Definitely.
Imagine trying to take that same weight up Mount Everest. That's even harder to do. That's a lot of work.
Right.
These spaceships are going up many times as high as Mount Everest, and they're a whole lot heavier than your 40-pound weight. So this is a lot of work.
So you need rocket fuel.
Exactly. Let's go back to the example of carrying the weight up the mountain. What do you use to fuel yourself to get that weight up the mountain?
You need energy.
Yeah,
So I would say a good nutrient-dense meal or two.
Food. Yeah.
Exactly.
You need food. You need calories.
Calories, energy.
Energy, exactly. And rocket ships need it too. They just have rocket fuel for that.
Yes.
And like I said, it's primarily kerosene with a few other liquid oxygen.
Okay.
I think they typically do. Might even be some nitrogen there. This is not my area of expertise, the types of fuels. They play with those fuels to try and get the most efficient, highest density energy combination. And what they essentially do is create a controlled blast inside the rocket.
Wow.
And so you get this explosion, and the explosion has so much force, and the only way that force can escape is at the hole of the rocket, the exhaust port. And so all this energy is forced through this tiny little port. And as we know from Newtonian physics, every reaction has an equal and opposite reaction, right? So a force that is pushing down
Will also be
will
pushing
also
up.
be pushing up. Exactly. And so that lifts the rocket. And so the primary expense here, in at least ongoing expense for flight, is getting the spaceship off the ground, which is fuel, really. But of course, there are also lots of other various expensive parts to it. Because weight is so much of a factor, you need to use very expensive metals and alloys when you're building the rocket
So that it stays intact.
so that it stays intact while also remaining light.
Ah, very
Right?
interesting. So performance appropriate.
Exactly.
Yeah.
So you need really strong but light materials. And why so strong? Because these rockets are moving faster than bullets, right? So if you fire a gun, this rocket would move faster than that bullet.
Wow.
That's how fast these things are going, many times
Yeah.
faster than the bullet.
And not to mention, there's lots of debris in space. There's lots of bits of things just flying, floating. They're floating and they're constantly floating because there's no gravity. And so you just end up probably running into a lot of that kind of debris. And there's also asteroids, and you have to be really careful in space.
No, that's a really good point. Yeah, there's what they call space junk.
Yeah.
Most of which is caused by us as humans. When satellites are decommissioned or they collide with something, they break into little pieces. And fortunately, space is really big, like
Yeah.
way bigger than we can really imagine. And so the risk of colliding with those things is actually extremely remote, except as you get closer and closer to Earth,
Yeah.
the orbit of Earth, the surface area starts to compress. The closer you get to Earth, the less space there is for things to move. And so as you get close to Earth's orbit, there actually is a decent chance that you're going to hit a little bit of this junk.
Wow.
And that's actually because of the speeds that these things are all moving at. In some ways, there's nothing you can do. They're going to cause serious damage, but they can track everything up to, I think, a couple centimeters. So they have a surprising amount of knowledge about to where those pieces of debris are.
So that they can divert their flight and they can navigate around the debris.
Yeah, exactly. And every now and then you'll hear about in the news a satellite that has to make emergency maneuvers to avoid space junk. China, I think it was China. I can't remember if it was China or Russia. I'm pretty sure it was China. Got in trouble recently because when you destroy something in space, let's say you're decommissioning a satellite, you're supposed to do that in a very controlled way where the pieces of debris come back down to Earth. You essentially let the satellite fall down. And instead, they exploded this thing. By exploding it, that caused debris to fly everywhere, and that's very hard to track. It's very hard for the other astronauts to avoid.
It's funny how we know about pollution in the water that we're trying to clean up. We know about air pollution. What about space pollution? I always wonder if there is debris that we are, mostly as humans, are to blame for, then we should clean it up. Is there a way of vacuuming it? You know what I mean? It would be very beneficial to, I think, the whole galaxy.
Yeah, at a galaxy level, that's probably never going to be a problem because, again,
So
space
vast.
is so vast, right? To think about a galaxy is millions of stars, maybe even billions of stars in just one galaxy. Our solar system is a solar system around just one of those stars. And think about how long it takes for us to go from Earth to Mars, the next planet in the sun's orbit.
Yeah.
From Earth to Mars. Do you know how long it takes?
From Earth to Mars, I would say maybe 10 years.
Not quite, probably 2 years. It depends on the orbit. So
Okay.
probably on some of the further orbits, that might actually be around 10 years. On a closer orbit, it's more like, I think 2 years, something like that.
Which is still a really long time.
Which is still an insanely long time, right?
Imagine-
The closest planet.
Can you imagine traveling anywhere for 2 years?
I know.
Right?
It's like we complain about when
2-hour traffic.
2-hour traffic, or when we're flying to Asia, that's 18 hours. If it's a really long flight, it's 18 hours. 2 years.
Years. Ugh.
And those are the people that are excited to go to Mars. That's what they're signing up for. 2 years
That's a really long
of
time.
travel.
So what
Yeah.
are some of the other implications for us as normal people? How are we going to be in our lifetime using space travel in our daily lives?
Yeah, one of the things I'm quite excited about actually uses space travel, but it's to get to other parts of Earth.
Okay, that's what I was going to hope.
Yeah.
I was hoping you were going to say that. Okay.
This is low Earth orbit transportation, right?
Yeah.
So there's different levels of orbit, basically the distance you get from the surface of the Earth. And the space station is actually surprisingly close to Earth. If you just had a piece of string that went from the ground to touching the space station, I think it's only like a couple 100 miles. You could drive that in a couple hours.
Yeah.
So it's not that far.
It's a shorter distance than going cross country in America.
Oh, much shorter. It's like driving from Philadelphia to a little bit
As
beyond
opposed to going East Coast, West Coast.
that. Yeah. It's a very short.
But it's vertical, so we don't
but
have
vertical, so it takes a lot of energy.
Yeah, and we've never done that unless you're an astronaut listening who's actually been to the space station.
Or if you've been on a climbing wall and you go directly straight up, that's a lot of work to lift your weight. Or if you're trying to do a pull-up in the gym. Again, going vertical is really hard.
I hadn't thought about that. No wonder pull-ups are so hard.
Yeah.
Because of gravity.
The common misconception is rockets don't fly vertically. You think of rockets as going straight up to the space station, for example. That's not actually how it works.
So how does it work?
They go on a curve, on an ellipsis.
Interesting.
Right? So they come up, and if you look at the streak of a rocket, it's not straight up. You'll see it curve.
So like a C shape?
Yeah, almost, exactly. It's a parabola. And the reason it does that is you have to escape the Earth's orbit.
Yeah, the orbit.
Right? It's the centrifugal force of the Earth, because the Earth is spinning.
Because otherwise you have to get out of it. It's going to keep turning around and around.
You'll get sucked back down. Exactly.
Right.
So things that are close to Earth and low Earth orbit aren't technically in orbit. They're really in a controlled fall around the Earth, which is very confusing to think. But the way it's explained to me is, if you take a baseball and you throw it, right, it'll go 10 feet and fall to the ground.
It'll curve.
It's a parabola. If you are super, super strong, you can throw it and it'll go probably another 20, 30 feet, maybe 50 feet. And then eventually it falls to the ground.
Yeah.
So if you think of a spaceship, what you're trying to do is launch it so hard and fast, like that baseball, so far, so hard, so fast, that as it's falling, it exceeds the curvature of the Earth. Right. So it's falling around the Earth, and you've accelerated it so fast that it's just falling around the Earth. And because it's going fast enough, it's not actually hitting the ground.
Yeah.
And that's what our space station is doing.
Oh my gosh.
It's not technically in orbit where it's floating by itself. It's just in a controlled fall around the Earth. And every now and then, it starts to get closer to the Earth, and so they have to push it back out a little bit.
Wow. How do they push it back out?
I don't know. I think they might use rockets. They might have rockets on board the station, or maybe they hook up a rocket ship to it to pull it back out. It's a question for an astronaut.
That's amazing. Okay, so let's go back to there's so much to say on this topic.
I know. We're like getting close to time, and we haven't even finished talking about the companies going into space.
So let's talk about the real world implications for this. We talked about the travel.
Okay. Going, as we said, going from the US to Asia takes anywhere from 12 to 15 hours to 18 hours, depending on where you're going.
Yeah, if you have a layover, which is when you stop at another airport in another country.
Then it's 20 hours or more.
It's so exhausting. We've done it all.
Yeah.
Exhausting.
It's long. And if you've done it, so take this instead. So an airplane goes up about 40,000 feet, right? That's about twice as high as Mount Everest. Okay. A rocket ship can go much higher, right?
Yes.
And because of that, it can escape the thicker, denser air. As you go higher into space, the air becomes less dense.
Yeah.
And the less dense air becomes, the faster the object can travel through that medium.
That makes sense.
So our air at the surface, atmosphere, is very thick.
Yeah.
And that's why if you're biking, you start to feel it on your face. If you stick your hand outside of a moving car,
you can feel
that wind.
The wind, yeah.
If you're really high up, like hundreds of thousands of feet in the
air thins out.
The air thins out. And if you stuck your hand out, you'd freeze, first of all. Yeah. But you wouldn't really feel any wind because there's not much resistance at that altitude.
And even at the Everest level, right, you hear stories about, there's very little oxygen. So people have to bring oxygen tanks with them, and it's very easy to asphyxiate.
Yeah.
And it's serious.
Oh yeah. So the air gets thinner. That's good for a vehicle.
Okay.
Because the thinner the air is, the less fuel it needs to move through it.
Yeah.
And the faster it can move without the materials burning up.
Yeah.
And so
overheating,
exactly, because friction creates heat. And so air even has friction. If you move fast enough, it actually causes things to burn. That's why a meteorite hitting Earth will burn up. You see a comet, that glow?
Yes.
That's the friction of it hitting the air.
Wow.
That's how hot and fast it's going.
Yeah.
It's incredible.
Incredible.
What does this rocket ship airplane do? This rocket ship airplane goes into orbit, basically like an ICBM, an intercontinental ballistic missile. It launches into
space
and drops back down within a matter of minutes in its destination location, right?
And it is going so fast. Can you imagine being a passenger? you really have to buckle in. You probably have to need more than just like an airplane
Seatbelt.
seatbelt. It's a full I bet it's a full harness.
Think about the training that astronauts need,
Yeah.
right? They have a lot of G-force training. The G-force is basically the gravitational force.
And they get into, I mean, this is why I really wanted to go to space camp as a kid. I think you did too. There were these like machines, right, where you get in, they're like a ball.
Yeah.
And you're basically floating and you're flying and you're getting twisted and turned upside down.
Around.
And apparently it wreaks havoc on your stomach because you're getting nauseated. But that's how you prepare for G-force.
G-forces,
Yeah.
exactly. So
Wow.
that's one of the things they're going to have to solve before this
Yeah.
comes mainstream. But the ultimate promise is you can get from the US to Asia in 45 minutes.
It's just
Something
crazy. It's
insane.
a marvel of technology. You can reach anywhere in the earth within 2 hours.
Yes.
Yeah.
Totally.
Yeah.
That's absolutely true. And so that's just such a cool thing, right? To get
Really
anywhere so quickly. Now, the question is, will that ever be affordable?
Yeah. Exactly.
Unclear.
Yeah.
Is that going to be terrible for the environment?
Yeah, that's another issue.
Probably. Will it actually happen? I don't know. Is it possible? Definitely. And probably celebrities and high-powered business people who need to get around quickly might use it. On the other hand, we have VR. So
Yeah.
is there really a need to get anywhere else in the world so quickly?
Well, I was also going to say, let's figure out VR technology first because there's so many kinks in that technology. It's really easy to get nauseated just by putting the goggles on and trying to be in VR world.
Yeah.
So let's figure that out first. And by us, I mean let's as a collective we,
Society.
like humanity.
Yeah. And honestly, fewer explosions too,
Yeah.
right?
Exactly. But the thought of it is really cool.
Thought it's really cool.
Yeah.
And what I'm actually personally very excited for as well is moon tourism.
Yeah, you know, it's funny. You just read my mind because I was about to say that people can now purchase tickets to the moon when that's available, but be like being on like a wait
A wait list?
Yeah, being on a wait list.
Really? There's already a wait list?
Yes.
For tickets to the moon.
Yeah, there already is. And
Those are some trusting customers.
And 5 years ago, it was like $1 million.
Oh my gosh. Well, okay. Let's just make sure we're not getting confused. You're not referring to, there are some trips that you can take into space where you do a circle around the Earth.
Okay.
And I think there might even be one that does go around the moon. So maybe that's what you're
Maybe
referring
that's
to.
what it is. Yeah, I just know that it's something about going from here to the moon. It's $1 million.
That must be it. It must be they do like a loop around the moon.
Maybe that's what it is.
Which is really cool. But what I really want is to land on the moon. I want to touch the surface of a alien planet.
That would be cool.
Well, moon isn't a planet.
Yeah.
But okay, it's a satellite technically.
You can tell we watch a lot of sci-fi and we get excited about it.
The fun fact about the moon,
Okay.
the dust is so fine,
Yeah.
the particulate matter,
Yeah.
that it can cause skin irritation and lung irritation.
Oh.
So one of the issues that the astronauts had when they came back onto the spaceship was cleaning off all that dust because it can get into the machinery, can get into so getting that dust off is because it's been pounded into tiny pieces over hundreds of millions of years of asteroids and meteorites hitting it. So.
Incredible. It's just so fascinating. So very fascinating. So we gave you a little glimpse of what sort of we're thinking about, what excites us with space travel. Obviously, like if you want to get into the more sci-fi, out there kind of discussion, of course, we're always game for that.
Yeah.
But just in terms of the potential for like great grandchildren down the line, their generation probably. But in our generation, it is there's an upside to it.
I think we'll get some of it, and we are benefiting in other ways, right?
Yeah.
We talked about SpaceX. We could do a whole episode on them. We should do a whole episode on them.
SpaceX,
But one of their big innovations is, the Starlink satellites that they're setting up. So
That
you
one's
get internet
huge
everywhere.
because that provides access around the whole entire world. So
that already affects it, right?
that
Part of space
for sure.
travel is not just for humans, it's for items, for goods and satellites.
Yeah, exactly. And maybe that'll make shipping goods also easier.
I'm not sure that we'll ever transport goods via space. We maybe do for like very high priority things that need to get somewhere quickly. But certainly shuttling resources from asteroids and from moons onto Earth.
Yeah. Even cleaning up the space.
That too.
I think that's an important one because if there's lots of space junk out there, we should
You don't want to hit it.
do something about it. Yeah. Anyway, so lots of really fun things to think about. We can go on and on about this. What are some of the things that excite you with anything that we discussed today? Are you pro space travel? Would you consider getting in a rocket ship if the opportunity were to present itself to you? What are sort of your thoughts around space? Tell us.
Yeah, we'd love to hear it.
Yeah, and we look forward to having you join us for another conversation with Greg and myself, and then I'll see you in another lesson very soon. All right, happy advanced English learning, everyone. Something very big is going live in January. If you've enjoyed the content we've put out on advanced English and Explearning, then you're going to love what is coming next. If you've wanted an opportunity to meet your fellow Explearners in a welcoming and dynamic environment, then what we have on the horizon is going to be perfect for you. So keep an eye out for more details coming soon, and make sure you're subscribed to our newsletter, which you can find on advancedenglish.co and explearning.co, because that's where you're going to hear it first. All right, see you then.